Hello, my fellow classmates and my TAs listening. The topic that I will be discussing to you would be strain. So what is strain? So when a force is applied to this object over here, it will cause a deformation here, whether it's stretching or compressing. And strain is used to measure this deformation of the object. So let's say in this case, there's this rectangular beam that if you're viewing it from the side, there's two equal forces acting on both sides that is pulling apart the beam from the middle. And the original length of the beam is designated by L, length, and this change in length on each side, which are equal in this case, are by this dashed line designated here, it's how much this side of the beam was stretched due to the force F. So strain. So how do we define strain? Strain is defined by this epsilon over here, Greek letter epsilon, is our change in length over our original length, which also our change in length could be designated by epsilon over L. Now let's talk about the sign conventions of strain. So when the strain, so F is an axial force or a normal force, which means it's a force that's perpendicular to the cross-sectional. Let's say this cross-sectional area here is a square. And this force is perpendicular. Let's say our page is our cross-sectional area. And so they're perpendicular. So this force is perpendicular. And this force over here is, in this case, it's tensile because it's pulling it apart from both sides, and it will be positive strain due to the tensile force because it's pulling it from both sides, causing the overall length to be greater than the original length. Now, let's say in a case where there's a force acting on both sides of the beam, causing it to shrink or get smaller or get compressed. And in this case, it would be negative strain by this epsilon here. Because it's getting smaller, the beam is shrinking. So the total length will be smaller than our original length here. Now let's talk about the dimensions or the quantity of strain. Strain is unitless, so it's change in length over L, which let's say it's millimeters over millimeters. It is a unitless quantity, but to signify strain, use the units of length over length. So this is metric, and for imperial units, it's inch over inch, let's say. However, this change in length compared to the original length usually is really small, and the number will be really tiny when we once calculate it. To combat this, let's say for metric, we use micrometers over millimeters because so the number, it works out for us and it's a really nice small number. It is a really nice, not a tiny number. Now there are two types of strain. In this case, one is normal strain and shear strain. So here, this is normal strain because the force acting on it is a normal force, which means perpendicular to the cross-sectional area. And this was our formula for normal strain. Now for shear strain, let's say we have a square plane here, and there's a force acting on this corner. This force will cause the paper, so these two sides, parallel sides, will shift with a certain angle. So this change in angle is designated by this y over here. So this change in angle designates our shear strain. And shear, so this force is parallel with the cross-sectional area. And that concludes our presentation for today, and I hope you guys learned well today. And if there's any question, let me know.